So the chemical energetics, energy change during a chemical reaction. So a reaction can be endothermic, exothermic, different categories of enthalpy change. It can be formation, if elements form a compound, combustion, if a substance, 1 mole of a substance is burnt completely. Enthalpy change of a reaction, it means that according to mole ratio, if we have the reactant in forming a product, and neutralization when 1 mole of a water is formed by reaction between acid and base. Atomization means when element form an atom in a gaseous state, and the Hess law can be used to find the energy change during a chemical reaction. Now example, using the Hess law to determine the enthalpy change of formation. Like if a question is there, calculate the enthalpy change of formation, or enthalpy change of formation is given. It can be, they can either give you or they can ask for enthalpy change of formation. So what you will have in this case, you will have reactant and product will be there. What link you will add? You will add an element in the standard condition. If in a question you will find a question is related to find the enthalpy change of formation, or enthalpy change of formation are given. So example, if we have a reaction, so example, we have a reaction in which say methane is burned to produce carbon dioxide and water. The equation must be balanced, so balancing start with carbon followed by hydrogen and at the last oxygen for combustion equation. And in the question, enthalpy change of formation is given. So what we will add here, we have reactant. So we have reactant. Reactants are forming a product. So what link we should add? We should add a link which we call element here. So element, what are the elements here? We have carbon. Only one carbon we need in a solid state. We need hydrogen. Hydrogen is H2, but we need 4 hydrogen atoms, so it means 2 hydrogen molecules should be there. And we have oxygen. So what will happen? Maybe the elements form the reactant and the reactant form a product, or element directly form the product. So the arrows from element should point out, because what happened, maybe first element form a product and element form reactant and then reactant form a product, or maybe element directly form the product. So if element directly form the product, or element first form reactant and then product, as you can see the two arrows are pointing out. If two arrows are pointing out, it means that is the beginning or the start of the cycle. Two arrows are pointing in, it means that is end of the cycle. So we can say delta, if this was delta H1, this is delta H2, this one is delta H3. So we can say delta H1 plus delta H2 is equals to delta H3. And that you will do if in the question enthalpy of formation is given, because formation means when element form a compound. So you should add always a link, a missing link, which is element. So now example, this is a question. What is the enthalpy change of this reaction? Aluminium react with magnesium, gives magnesium oxide plus aluminium. So, and this enthalpy change of formation is given. So if enthalpy change of formation is given, what we will do? we will add a link here. Which link we will add? We'll add elements. So what are the elements in this reaction? We have aluminium. We need 2 aluminium. We need magnesium. And we need oxygen. How many? 3. So how we can have 3? Means it will be 3 by 2. So that will have 3 oxygen. Now what happened? These elements may form the reactant and reactant form a product, or element directly form the product. This is the enthalpy change which we need, or which is unknown. You can say X, which is unknown. Now, aluminium, magnesium and oxygen react and they form aluminium oxide and magnesium. So if they form aluminium oxide and 1 mole of aluminium oxide is formed, so it means this is a standard enthalpy change of formation of aluminium oxide. And magnesium was there before and after, so it means magnesium is not formed. Here the formation of the element or magnesium is 0, because in the reactant also we have magnesium, and the product as well we have magnesium, so magnesium is actually not formed here. Then aluminium, magnesium and oxygen react, form magnesium oxide and aluminium. So aluminium is not formed, it is before and after, it is same. So here magnesium is formed. So this is standard enthalpy change of formation of magnesium oxide. But how many moles of magnesium oxide are formed? 3 moles. So it means this is multiplied by 3, because for 1 mole that is delta HF magnesium oxide, but for 3 moles it will be 3 times. So when we apply the rule, as you can see, the 2 arrows are pointing out. So where the 2 arrows are pointing out, that is the start or the beginning of the cycle. And the 2 arrows are pointing in, that is the end of the cycle. So formation plus X means this will be standard. When I apply the rule, standard enthalpy change of formation of aluminium oxide plus X is equals to 3 times the standard enthalpy change of formation of magnesium oxide. If we need X, this will move other side and we will get the value for X. So you can see 3 multiplied by formation of magnesium oxide minus formation of aluminium. What we will get? We'll get the enthalpy change of this reaction. So this method, this technique you will use. You will have reactant in product, but you will add a link. And how you will know what link you should add? If the reactant formation is given, you will add this link of elements. Is it clear? Because there are different types of questions related to Hess law. This is one of them. Is it clear to everyone? What about others? To everyone it is clear? Now, another type of reaction. First example and then another type also we'll discuss. Like example, the question equation will be there. So let's hide this all. And we'll try to solve. So this is the equation given, and using the following data calculate heat of combustion of propene. So propene is burned, it produces carbon dioxide and water. Now, because you can see the formation is given, so formation is given, it means we have to add a link which is element. So what are the elements here? The element is carbon, hydrogen and 9 oxygen. To have a 9 oxygen, it will be 9 by 2 or 4.5. So element form a reactant or element directly form the product. As you can see here, carbon, hydrogen and oxygen react, we form propene and oxygen. So oxygen is not formed here, it's before and after same. So basically it is enthalpy change of formation of propene, which is C3H6, and carbon, hydrogen react to form and oxygen react to form carbon dioxide and water. So this is the formation of carbon dioxide. And how many molecules? Because 3 molecules are there, so multiplied by 3. Plus water is also formed, so 3 molecules of water are formed, so standard enthalpy change of formation of water. And this is the unknown X. So when I apply the Hess law, this is where the 2 arrows are pointing out, that is a start or the beginning of the cycle, where 2 arrows are pointing in, that is end of the cycle. So this plus this, so standard enthalpy change of formation of propene C3H6 plus X is equals to 3 times the formation of carbon dioxide standard plus 3 times the formation of water molecule H2O. And then we need X, it will move other side, we'll subtract and get the final answer. Is it clear, this example? The example 2. Same way, some of the reactions, combustion is given. Combustion means burning. So if combustion is given, what you will do, you should add a combustion product like burning product for reactant, and burning product like burning result, combustion product for burning the product. So the same way we will solve here. The start of the cycle will be the reactant and end of the cycle will be the combustion product. So root 1 or root 2, the overall energy change will be same. So example, using the Hess law to determine the enthalpy change of combustion, you have say carbon monoxide reacted with hydrogen to form methanol. The question is, use the following combustion data to calculate heat of the reaction. We need this X. Now, and the combustion data is given, like combustion values are given if you burn carbon monoxide, if you burn hydrogen, and if you burn methanol, what will be the product? So if you burn carbon monoxide, it will give carbon dioxide. If you burn hydrogen, it will give water, or if you burn methanol, it will give us carbon dioxide and water. So as you can see, this will be the start of the cycle and the other one will be end of the cycle. So enthalpy of a reaction plus combustion of methanol is equals to enthalpy of combustion of carbon monoxide plus twice the enthalpy of combustion of hydrogen. Why twice? Because you are burning 2 moles of hydrogen. So enthalpy of reaction will be combustion of methanol minus the combustion of carbon monoxide, like the combustion of carbon monoxide and combustion of hydrogen minus the combustion of methanol, you will get this delta H for this chemical reaction. So again, like if you want to solve this, as the combustion values are given, three carbon plus three hydrogen gives C3H6. If we burn this, what it would be, because for burning we need oxygen, so if we burn, it will give carbon dioxide and water. But the equation must be balanced, like in terms of you need three carbon and you need six hydrogen. For oxygen it's not necessary, because oxygen is not the main reactant, so it will not make difference. And if you burn propene in the presence of oxygen, a complete combustion gives carbon dioxide and water. Now, we need this energy change, enthalpy change of formation, because when elements form a compound, that's called formation. So this is what we need. But because in the question combustion is given, so we add a combustion product. A reactant can burn and form a product. The product can also burn to form the product. So we are burning 3 moles of carbon. So this will be standard enthalpy change of combustion of carbon plus 3 times the standard enthalpy change of combustion of hydrogen. And here we are only burning 1 mole, so this will be standard enthalpy change of combustion of C3H6. And when we apply the Hess Law Cycle, as you can see, the two arrows are pointing out. That is the beginning or the start of the cycle. And the two arrows are pointing in. That is the end of the cycle. So this will be X plus standard enthalpy change of combustion of C3H6 will give 3 times the standard enthalpy change of combustion of carbon plus 3 times the standard enthalpy change of combustion of hydrogen. And we move that other side and find the unknown X, which is of formation. Is it clear? So using, the important thing is the arrows, the position of the arrows, the direction in which these arrows are pointing. Is it clear to everyone? Any doubt? Now, experimentally, how we can find the enthalpy change? Basically, this is normally done for a reaction in which we can add a water or in aqueous solutions, or if an exothermic reaction is there, the water can be used to absorb the heat energy, and the heat energy which is absorbed by the water is given by Cm delta T, where C is a specific heat capacity, M is the mass, and T is the temperature. So we can use this formula in physics. Energy, when we calculate, energy is equals to Cm delta T, specific heat, multiplied by mass, multiplied by temperature change. We can find how much energy is absorbed by the water during a chemical reaction. And using this, how much energy absorbed by the water divided by the number of the moles, we'll get the enthalpy change per mole. So, example, if you want to work out a chemical reaction is there and we want to calculate the enthalpy change for this chemical reaction. So to use this formula, E is equals to Cm delta T. C is the specific heat of the water which is fixed 4.2. M is the mass of water because we consider the density of the water is 1 gram per centimeter cube. So if density is 1 gram per centimeter cube, it means the volume of the water is same as the mass of water. Like example, if I have 20 cm cube of water, it means I have 20 grams of water. That is our assumption that water density is 1 gram per centimeter cube. So mass also we don't have to measure, we just measure the volume and the volume of the water will be the mass of the water. The next thing is temperature change. The temperature change is the difference. So how we can work out, so we can use a graph for this purpose. Example, in this graph, because to calculate a temperature change, we should know the initial temperature, we should know the final temperature, and the difference in the temperature will give us the temperature change. So we will monitor the reaction over a period of a time and work out the temperature change. So example, say a reaction is there, we are monitoring or we are measuring after every 30 seconds we are measuring a temperature. So first 30 seconds, then 1 minute, then 1.5 minutes, then 2 minutes, then 2.5. And when 3 minutes are there, first till 3 minutes we did not add the reactant, we are just measuring the temperature of the water. Then we add the reactant, and the moment when we add the reactant, the reaction start. We will continue recording the temperature after every 30 seconds. So like example 4, then 5 and 6 and so on. Continue. So we'll have this type of graph of this pattern will be there. So using this pattern, like these are the points which we will have when we plot our result. How can we work out the maximum temperature or the temperature change? So for this purpose, what we do, the moment when the reactions start, like example, if we add a reaction mixture at 3 minutes, so we'll draw a perpendicular 90 line, vertical line at the moment when we mix them, and we will draw another line to show a decreasing temperature, like which is showing that the temperature, like reaction completed or temperature is decreasing. The point where the two line will intersect, that is the final temperature. So we have the initial temperature, we have the final temperature, and when we take a difference of the two temperature, we will get the temperature change, and we substitute in the formula to know how much energy released or how much energy absorbed during this chemical reaction. Is it clear, this technique? Measuring a temperature change to work out the energy change during a chemical reaction. But what are the errors in this method? What are the wrong assumptions or things leads to error or wrong result? Heat energy transfer from surrounding, or heat transfer from surrounding, if it's a cold, like if a substance is having a low temperature, heat transfer from the surrounding, and if it is hot, heat transfer to the surrounding. That is one thing. Approximate specific heat capacity of a solution is used, like we assume that the solution is a pure water which is having a specific heat capacity of 4.2, neglecting the specific heat of the calorimeter and ignoring the heat absorbed by the apparatus, because even like we have a mixture and the solution is there, we place a thermometer inside, but we did not include like that the thermometer will absorb energy. We neglect, or calorimeter absorb energy. We neglect all the factors, and reaction or dissolving may be incomplete or slow. So this reaction might be too slow, so it causes a temperature change, but maybe that is smaller than the least count of the thermometer, so it will not be accurate. And the density of the solution is taken as same as the water, but in practical the density will be different. So when we use this calorimeter method to calculate the enthalpy change or energy change during a chemical reaction, we assume that it's a pure water which is having a density of 1 gram per centimeter cube, but in practical it is not having the same density. But these are all assumptions for our calculation. So using the formula, we can work out the enthalpy change. Then we divide by the mole, we'll get enthalpy change per mole. Normally, then this answer will be in joules. When you work out, you will get answer in joule. Then convert into kilojoule, and kilojoule divided by the number of mole, you'll get kilojoule per mole, which is called enthalpy change of reaction, combustion, according to the question. As you can see here in this example, calculate the enthalpy change of a reaction for reaction where 25 cm cube of 0.2 mole per copper sulfate was reacted with 0.01 mole of zinc, and the temperature increased by 7. So what you have a copper sulfate solution which is having a volume of 25 cm cube. So when we say we have 25 cm cube copper sulfate solution, so how much water is there? The water is also 25 cm cube. And if water is 25 cm cube, we assume that the density of water is 1 gram per centimeter cube. So what will be the mass of the water in it? That will also be 25 grams. So we have to calculate the energy change for amount of reactant in the test tube. So energy is Cm delta T. M is the mass. Why we took 25? Because the volume of the solution is volume of the water in it, and volume of the water is same as the mass of the water. The specific heat of the water is 4.18 and temperature change is 7. So when you multiply, you will get 731.5 joules. Then to get the moles, because calculate the number of reactant which are not in excess, because the energy release depends on the limiting reagent, not the excess one. So concentration, moles is concentration into volume. So concentration multiplied by volume will get the moles. And to get how much energy released for each mole, so energy divided by mole, so we'll get energy which is joule per mole, but we normally get the answer in kilojoule, so we divide by 1000 to get answer in kilojoule per mole. Because the temperature is increased, if a temperature increase, it means the reaction is exothermic. That's why the final answer should be negative minus 146 kilojoule per mole. And when you write this answer, your answer should be in 3 significant figures. Is it clear, this example for enthalpy change of solution? So even here, what even for example, if they ask like what could be the sources of error here, so the sources of error, as we discussed, maybe some of the heat transfer to the surrounding, maybe the specific heat capacity of the solution, we assume it's same as for water. That is the wrong assumption. We did not consider calorimeter, even the copper which is formed absorb energy, and maybe the reaction might not be complete, or the density we took of solution is same as for water, but in practical it will be different. Another example you can see, when 25 cm cube of HCl mixed with 25 cm cube of sodium hydroxide, the temperature increased by so if 25 means how much water will be there? 50. That's why volume of water is 50 or volume of solution is 50. So volume of water will be 50 and the mass of the water is also 50. Specific heat of water multiplied by temperature change, we get energy. Energy here, there is no limiting reagent because the ratio of them is 1 is to 1. So any one of them moles you can take, and energy divided by moles, you will get energy per mole, and divided by 1000 to get energy per mole in kilojoule per mole. And the negative sign, why negative sign? Again, it's an exothermic reaction. So enthalpy change for exothermic reaction is always negative. Is it clear, this example as well? We normally, when we are mixing two solutions, we leave them for some time so they both reach the same starting temperature. And then we mix them into another a large container and record the temperature. Is it clear, this part as well? The enthalpy change. So today we started the chemical energetic with bond energy, the energy diagrams, then enthalpy change of the definition you have to learn for neutralization, atomization, combustion, formation, and Hess law. The overall energy change is independent of the route or the path which we follow. So we can use it to find normally for endothermic reactions. If enthalpy change of formation is given, we'll add elements. If its combustion is given, we'll write the combustion product. And practically, we can use a calorimeter to find the enthalpy change of a chemical reaction. E is equals to Cm delta T, we'll get the energy, and energy divided by moles, we'll get energy change per mole. So next session, we will do more questions and examples related to enthalpy change of combustion using the calorimeter. Any question related to the class? So I'll end the session and share this recording.